fusion. It's what powers the sun and what could power Earth one day. But what exactly is fusion, and how does it work? Fusion is where two nuclei combine to form one larger nucleus, releasing energy in the process. In fact, the energy released by the fusion of just 1 gram of hydrogen is equal to about 2,400 gallons of oil, which could power your home for almost a decade. But why does it release so much energy? There are two forces responsible for this release of energy: the electrostatic force and the strong nuclear force. We'll call them the electric force and the nuclear force for short. The nucleus is made of protons and neutrons, called nucleons. The nuclear force is the attractive force between nucleons, and the electric force causes protons to repel. The nuclear force is very strong, but only acts over very small distances. The electric force is weaker, but acts over much greater distances. So the nuclear force is holding the protons and neutrons together in the nucleus, but the electric force is pushing the protons apart. Adding nucleons increases the nuclear force of attraction, but the added protons increase the electric force of repulsion. Since the nuclear force is stronger, adding nucleons will increase the total attractive force in the nucleus. However, as the size increases, the nucleons get farther apart. At longer ranges, the electric force is stronger, so the farthest nucleons will be repelled by the added nucleons more than attracted. So at first, adding nucleons will hold the nucleus together more tightly, but after a certain point, the opposite happens. But what does that have to do with fusion? When you fuse nuclei, you're really just adding nucleons, so fusing small nuclei will make a nucleus more tightly bound, but fusing larger ones will do the opposite. When the nucleons are held together more tightly, they can't move around as much, so they have less potential energy. If the product of the fusion reaction has less potential energy than the original nuclei, that means the energy was lost. That energy is accounted for in the form of mass, where the product nucleus has less mass than the total starting mass. The energy is released in the form of heat and light, which is what we observe from the sun and possibly what we could harness to power Earth.